This video covers part of Chapter 4, Section 6, which deals with a couple of theorems that involve isosceles and equilateral triangles. Before we get to those, first we need some vocabulary about isosceles triangle. So you should already know that an isosceles triangle is a triangle with two congruent sides, in this case, side AB and AC. And those congruent sides we just call the legs of the triangle. So an isosceles triangle always has two legs, and in this instance, it is segments AB and AC are the legs. That third side that's not congruent to the other two is called the base. So in this case, that is side BC. We also have some terms to talk about the angles. One term is the vertex angle, which is the angle opposite from the base. It is also the angle that is between the two legs. So in this case, that is angle A, right? Angle A is right across from the base and is between the two legs. And then our base angles are angles adjacent to the base. So in this case, that is the other two angles, angle B and angle C are adjacent to side BC. All right. We also have an isosceles triangle theorem. And the isosceles triangle theorem tells us that two sides of a triangle are congruent if and only if the angles opposite those sides are congruent. So you'll notice this if and only if. This is a biconditional statement, which means that if a triangle has two equal sides, then it has two equal angles, and vice versa. If it has two equal angles, it has two equal sides. And it is the angles opposite the sides that are congruent. So in this case, our base angles, angle B and angle C, have to be congruent. And it's always going to be across from these two sides. So angle C is across from side AB, and angle B is across from side AC. B and C are congruent because AB and AC are congruent. That is an example of the isosceles triangle theorem. So two equal sides imputes two equal angles. All right, let's put that in practice to solve for some missing angles in a triangle. Here we have an isosceles triangle with legs DF and EF, and we want to figure out the measure of the two missing angles, angle D and angle F. So we just said that the angles across from the legs have to be congruent. E is across from one of the legs, D is across from the other leg. So if angle E is 74, angle D is also 74 degrees. All right, now that we have two out of the three angles of a triangle, we can find the third by using the triangle angle sum theorem that we learned earlier on in chapter 4, which tells us that the three angles must add up to 180 degrees. And then we just have an equation that we can solve for x. 74 plus 74 is 148. Subtracting 148 from each side gives us 32 degrees for angle F. All right, let's look at one more example of this. Here we have an isosceles triangle again. This time, we're given a vertex angle equaling 110 degrees. J and K would be the base angles, which would be congruent to one another because they are opposite the legs. And we are going to find the measures of those two angles. So just like we talked about before, these three angles together must add up to 180. So let's figure out how many degrees we have left. 180 minus 110 is 70. So J and K together must add up to 70, but we know J and K are equal. So we can just divide 70 by 2 and get 35 degrees for each of those two angles. We have three angles that add up to 180 with the base angles being congruent. So that's isosceles triangles. We also have a theorem that has to do with equilateral triangles. And the equilateral triangle theorem tells us that a triangle is equilateral if and only if it's equiangular. So an equilateral triangle has three equal sides. An equiangular triangle has three equal angles. And so if it's one, it has to be the other. So here we have three equal sides, and that means we have to have three equal angles as well. Something we talked about earlier on in the chapter is that an equiangular triangle must have angles that are all 60 degrees, because 60 plus 60 plus 60 gives us 180. So if they have to be equal, the angles are always 60 in an equilateral or equiangular triangle. All right, so let's combine these two things together to solve a problem. Here we have a diagram, and we are going to figure out the measures of a few different angles. Angle Y angle WZX and angle XY or XWY. So before we solve this question, let's talk about these three angles and where they are in our diagram. So let's draw first here. If we have angle Y, that would just be this angle right here. So for angle Y, we're trying to figure out how many degrees that angle is. All right, let's change colors here. All right, for angle WZX, that would be this angle right here. Trying to figure out how many degrees that angle right there is, right? WZX, Z is the vertex, W and X tell us the sides of the angle, and lastly, XWY, W is the vertex, X and Y are the sides, and so for this angle here, we are talking about this angle, this whole thing. Okay, awesome. Now, based on that, let's think about what we know. Well, first off, this triangle right here, triangle WYZ, is an equilateral triangle, which means all of the angles must also be the same and they all must equal 60. All right, we got a 60, a 60, and a 60. Awesome. All right, now let's look at this triangle here, triangle WXZ. In this triangle, we have two equal sides, which means it's isosceles, which means we have two equal angles. And those equal angles would be angle X and angle XWZ, this angle right here, right? They're across from the two legs, which means they must be equal to each other. So if we got a 50 here, we've also got a 50 there. Okay. Lastly, we need to figure out what this angle is right here. We know 50 plus 50 is 100. So that means there's 80 degrees left in this triangle, which is going to go right here. Okay. So now that we've filled everything in, let's answer our questions. Angle Y, that's right here. That's 60 degrees. All right, next one. WZX, that's right here. That's 80 degrees. And XWY, that's this whole angle right here. So 50 plus 60 gives us 110 degrees.